Hey folks, welcome to the next class in the series of Basics to Advanced. And in this class, we are going to talk about the most fundamental topic of arithmetic. We're going to begin with percentages. Now, if you are starting your prep with arithmetic, of course, the go-to topic has to be percentages. That has to be the first one, because invariably every question has some idea of percentages sitting in it. So, the most important topics automatically become percentages, ratios, and linear equations across the entire section. So we're going to start with percentages. We'll understand how to look at those numbers, how to look at a percentage, how to convert them, what is the percentage increase, decrease. This is what we are going to talk about. So to give you one heads up, the session will all be about fractions, percentage changes, successive changes, and then a couple of properties that we use, and then we'll look into a few problems. That's going to be the session all about. Now to begin with, when I say percentage, what is it? So what is a percentage? Now, is it really necessary to have percentages? A question that I ask, and my answer would automatically be yes. Why? Now, a lot of times people say to convert, to look at data, to compile them. Of course, percentages are helpful there. But the most important part where percentages help us happen to be to compare. When you're comparing elements, when you're comparing something, now rather than looking at data, it's always convenient to look at percentages. Of course, compiling data and automatically also compare. To give you an example, let's say if someone scores 350 marks and there's another guy who scores 720 marks. If I ask you who has scored better, our minds would automatically say, hey, 720 seems to be better, right? But if I say this 350 is out of 500 and this 720 is out of 1500, now do we still say this 720 is better? Numerically, yes. But as marks, would you say 720 out of 1500 is better? No. Now this is where we might have to bring them to a common base and then compare them, and that common base will be 100. So 350 by 500, so all I want to do is just multiply it by 100. So this will give me, cancel out the zeros, you get 70 for every 100. You are taking that average for 100, that's all. So 350 out of 500 is nothing but 70 for every 100. If I do the same thing over here into 100, 2 zeros gets cancelled, 15 goes here 4 times, and then 8 times, 48. So this will be 48 for every 100. Now here this guy has scored 70 for every 100 and this guy has scored for 48 for every 100. So we say this is better. So instead of saying 70 by 100 or 70 per 100, we simply say this is 70 percentage. This is 48 percentage. Percent, every 100. That's the key here. So the moment you know how to convert them, we understand what goes and how value changes, what should be done, and compiling and comparing data becomes a lot easier. So percentage is nothing but per 100, every 100. That's all. So in percentages, there are two values that we are super important. That's going to be super important. One, the base value, and then the percentage value. What do you mean here? So when I say 70%, the question will be 70% of what? When you say a percentage, what is important? The percentage value is important. So is the base value. Now if I say I got 40%, now you can look at 40% as a value itself, 40% of something. But sometimes we also need 40% of what? When I say a percentage of B, that is where we get our value, which is written as A by 100 into B. Clear? So the moment you plug this in, you know how to write something, we are through. What percentage of A is B? If the question goes, what percentage of A is B? Here the question would have been, what is A percentage of B? Here the question is what percentage of A is B. So the word shifters takes a different place. The meaning of the question changes. So they are asking us what percentage of A is B. So B is some part of A. So what percentage is that? Here you write it as B by A into 100. Here the question will be what is A percentage of B? Here what percentage of A is B? So you have to read the question clearly while solving them. So this is fine. If I give you some numbers and if I ask you to find the value, we wouldn't have a lot of trouble doing it, right? Per se, if the question is 50% of 36, you look at the number and then you will spontaneously say, hey, the answer will have to be 18, right? Meanwhile, when I'm writing it here, you're already calculating it and you're putting it down on your paper, right? So 25% of 80, you'll automatically say that's 20. 10% of 73, 7.3. 1% of 121, I know you are shouting behind the camera there, 1.21. Super nice, super easy, right? But if I ask you a few more questions, now if I say 66.66% of, then what will you do? This is where it gets tricky. Now we'll have to manually multiply it 66.66 by 100 into 42 and then you do the math. It's a painful procedure, right? Now if you go back here and then look at this and then think how was this easy and this is getting difficult, the answer lies in the fact that how do I look at those numbers? Now the moment I say 50%, your mind doesn't operate it as 50%. You are thinking about it as half of a value. Why? 50 by 100 is equal to 1 by 2, right? That's what we say. 50 by 100 is equal to 1 by 2. If I say 25%, you are looking at a quarter of a value, not 25 by 100. Of course, 25 by 100 simplified is 1 by 4. But our mind doesn't think about it that way. Our mind simply says 25% is a quarter, 10% is 1/10, and 1% is 100. So every fraction we are computing it to be every percentage we are computing it to be a fraction, which makes our job super easy. Now if you know how to rewrite 66.66, it becomes easy, right? Now let's try writing every value. If I say 1 by 2, you know that's 50%. If we continue to do that in a pattern, let's write down all the numbers and then we'll see if it will be helpful, if it will be convenient to solve questions. If I say 1 by 2, you know that is 50%. 1 by 3 will be 100 by 3. Think about 1 by 3 as 100 by 3. That's all. So this will become 33.33%. 1 by 4 is easy, 25%. 1 by 5, 20%. 1 by 6, I can say it is half of 1/3. So half of 33.33 will become 16.66% or 16.67. You can write 16.67. 1 by 7, that's a nice way to remember 1 by 7. Simply double 7, you get 14. Double 14, 28. Double 28, you get 56. You add plus 1 to it, 57. 14.2857%. The reason why I write it to 4 decimals is that 2 by 7, 3 by 7, all the parts of 1 by 7 will take digits only from here. It's called magic circle. We'll talk about it later. But then 1/7 is 14.2857%. 1 by 8 is 12.5%. 1 by 9, 11.11%. Or think about it as 1/3 of 1/3 is 1/9, 11.11. 1/10 will become 10%. 1/11, 1/9 and 1/11 form a pattern. If you look at this, 1 by 9 is 11.11. 1 by 11 is 9.09%. 1/12 is half of 1/6 again, so 8.3. Now if you can convert percentage values to fractions, it becomes a lot easy for us to solve these questions, right? Now we'll use these fractions and see if we can solve any of the questions given here. So let's look at a couple of more questions. Now looking at this 66.66% of 48. Now rather than writing it conventionally, I'm thinking, how can I rewrite 66.66%? Look at the table here, and then I'm noticing which one will work. 1/3 is 33.33. 2 times 33.33 is 66.66, or I can call it 2/3 of 48. So now it gets a lot easier to cancel 316 times, so this is 32. That's all. Now do the next one. I look at 45.45% of 77. What can be written as 45.45? For 9.09 into 5 is 45.45. So it will become 5/11 of 77. Cancel this 7 times, so this is 35. Now 5.555% of 80. Now your minds will automatically say, hey, we can take 5/9. 5/9 is 55.55, but I need 5.555. So it cannot work 5/9. Your minds will now say, hey, let's do 5/90. 5/90 is good. I look at 5/90 and then realize, hey, I can still write it as a fraction, but then I have to divide by 90. So writing this to be 5/90 into 80 works, no doubt about it. But the problem here is I might have to again divide it by 9. So, and we have to keep going. Rather, what I'm going to do is I want to split this. Split percentages. Sometimes when you cannot rewrite it as a fraction. For example, there is no way you can write 41%. Think about 41%. What will work for 41%? Nothing. 41/100 cannot be simplified. So there's no other way you can write 41%. What I can do is I can break them down and then compute it. How? If I'm looking at 41%, I can write it as 40% plus 1%. So because finding 40% is easy, find 10% into 4, find 1%, add them, you are done. If the question is 29%, find 30% minus 1%. If the question is 55%, 50% plus 5%, we get the answer. So splitting makes our job a little easier. If not, we always have the comfort of a calculator, but sometimes using your minds to do a math is also fun. So for the sake of that, how can I split 5.555? You can think about it as 5 plus 0.555, but I want to further break it down. 5% plus 0.5% plus 0.05% plus 0.005%. Right. So what is 10% of 88? So 5% will be half of that. So it will be 4. If 5% is 4, 0.5% will be 0.4. So this will become 0.04 plus 0.004. So the answer is 4.444. Now when you do this here, you will get 4.44444. You will have a recurring decimal, but here I'm getting it to the accurate position place of decimals because the question is 5.555. So it doesn't matter. You can still write 4.4444 dot dot dot. The answer is still right, but this is a lot easier to do in your head. That's the key. So pick and choose what you want to write as fraction, which numbers you want to break it down, and then think about it. By persistent practice, you will get an idea about how this is done. Now obviously, if the value changes from one thing to another, there is a change in value, so is there a change in the percentage. Now, for example, if there is a cost of, let's say, 1 kg of apple is 40 rupees last month, this year it has gone up to 48 rupees. So there is an increase in the price, so there is a change in the percentage as well, right? So what is the percentage change? How do we do it? The formulaic way usually says percentage increase means final minus initial by initial into 100. Percentage decrease is initial minus final by initial into 100. That's how the formulaic way goes. But I want to think about it in a slightly easier variant. Rather than using formulas, I want to look at a number and then think about it. So every time I look at a change happening from 40 to 48, ask yourself two questions. What is the change? From where is the change? Always. These are the two questions that should come to your head. So from 40 to 48, so the change has happened from 40 to 48, right? So what is the change? 40 to 48, the change, it has increased by 8, and it has increased by 8 from where? From 40. So it will be 8 by 40 into 100, or it is 1 by 5 into 100, or that is 20 percentage increase. So in my head, usually I say percentage change is equal to difference by base into 100. By base, we are referring to from where did that change happen. We are not looking at the final value. We are looking at the initial value. So difference by base, wherever the change happened from a base, that's what we are saying it as my denominator. So difference by base into 100. What is my difference? Divided by from where is my difference into 100. And that will be our answer. So let's quickly solve a few basic questions and establish our fundamentals here. The first question says, a warehouse stores 37% electronic items and the rest are furniture items. If the difference between the number of furniture items and electronic items is 40, what is the total number of items in the warehouse? So clearly says that there is a total number of items. I'm going to call it, let's call it T, total value, out of which 37.5% are electronics, whereas the remaining 62.5% are furniture items. That's given by data. Now, the conventional way would be to say the difference between the items is 40. So you'll say 62.5% of the total minus 37.5% of the total is equal to 40. You would be writing 62.5% of T minus 37.5% of T is equal to 40. And then we solve for it. But the simpler way would be to look at this as, hey, 62.5%, the other one is 37.5%. The gap between them is 25%. So we can conveniently say 25% of the total is equal to 40. 1/4 of T is equal to 40, or total is equal to 160 items. And that will be our answer. You can do this too many steps, but then I look at this, the variable here on both occasions happen to be same. I can conveniently say 25% of the total is 40, so the total is 160. As simple as it goes. Look at the second question. There goes a saying, we say every word matters. I don't know where and all it is true, but it is definitely true when it comes to your competitive exams, because you misread one word, the meaning of the question changes. One classic example is here. If you look at the three questions given here, you will think about it as all three questions are same, but in reality they are not. So when you look at the question, the attendance at a seminar decreased by 20%. Now that's the standard statement across three questions. But the first question says decreased by 20% to 120 students. So it is telling you that after decrease, it has gone to 120 students. So in the first case, my final value is 120. But when you look at the second question, it decreased by 20% from 120 students, which means initially there were 120 students, then it decreased by 20%. The initial value is equal to 120. Whereas in the third question, you can either say decreased by 20% or 120 students, or it is simply telling you that the decrease is 120. So if I think about this, there's an initial value here. There's a 20% decrease, or I can call it 1/5 decrease then comes to 120. So we can say this is 4/5 of your initial value. So I can say 4 by 5 of initial is equal to 120, or my initial value is 120 into 5 by 4. You will get this to be 120 into 5 is going to be 600 by 4, 150. So the original attendance, initially there were 150 students, then dropped by 20%, which is 30, went to 120 students. When you look at the second case, 120 were there, it has gone down by 20%, which is a 1/5 decrease. So I need my final attendance. So I can say 1/5 gone means my final would be 4/5 of my original value. My final value will be 4 by 5 times of my initial value, or my final attendance is 4 by 5 times of 120. So you will get 120 divided by 5 is 24. 24 into 4, my final value is 96. So here this is 96. Here this is 150. But whereas in the third case it has decreased by 20% or 120 students, it is telling us, hey, there was an initial value, there's a 20% decrease, or I can call it 1/5 decrease, and I've gotten my final value. This 1/5 decrease is 120. 1/5 decrease of my initial is 120. So I can say 1 by 5 times of I is 120, or my initial attendance is 600 here. One word changes, your answer also changes. The scenario also changes. So be keen on every word. Ensure that you get every information right before you start solving a question. Right? We'll hop on to the next one. Another question here. The number of trees in park A is 25% less than the number of trees in park B. If park A has 180 trees, how many trees are there in park B? So the number of trees in A is 25% less than the number of trees in park B. So whatever park B has, park A has 25% less. So I can say A is equal to 75% of B. Right? Looking at 75% of B is A. Park A has 180 students, 180 trees. A is equal to 180. What is B is equal to? So I can say A is equal to 3 by 4 times B. We need B. So B is equal to 4 by 3 times of A. B is equal to 4 by 3 times of 180, which we know by data 60, or B is equal to 240. So park B has 240 trees. Park A has 180 trees. So simple ideas, get to the fundamentals, solve a few basic questions before you hit the intermediate questions, so that you build that comfort level of solving questions. So we'll solve a few more questions in the next class. In the meanwhile, if you haven't joined the groups, once again, have a look at them, scan the QR codes. It will take you to the groups. Any discussion, we have it over there. If you are done with this class, best wishes.